All right, our last section in Module 13. And we're going to be talking about absolute values that have inequalities. So we're going to see inequality sign greater than or less than in relation to absolute values. And we're going to do this guy here. It's possible to get more than two solutions with an absolute value. That means sometimes we're going to get a wide variety of solutions with the inequality as well, and I'll show you some of those types right here. The shading is going to look a little bit different on some of these solutions than we've seen in the past. This says determine whether each of the integers from -5 to 5 is a solution for this inequality. Absolute value of x plus 2 is less than 5. So let's just plug them in right here. So anything I plug in here gets positive, so that would be positive 5 plus 2, which is 7. Positive 4 plus 2, which is 6. And we can see that's going to go 5, 4, 3, 2. And then it starts going back up. That's 1 plus 2, which is 3, 4, 5, 6, 7. I should have written yes or no, but we will. All right. Write yes for each number in the table that's less than 5. Well, that would be yes here. I'm just going to put y's, yes, yes, yes. So it's everything in there, right? And then it says if the number is a solution, plot it on the number line. So it looks like we have from -2 as an input, so -2 all the way up to 2. Everything in here, right? Those are all the ones we have. This one says determine whether each integer is greater than 5, which you already done, right? We still got 7, 6, 5, 4, 3, 2, and it should be the same, 3, 4, 5, 6, 7. And we're going to say yes next to all the ones that are greater than 5. That's this one, and this one, and this one, and this one. And let's plot it. Now I'm going to do something weird with these plots, right? It looks like -5 and 4 right here on this side, and 4 and 5 on this side. Now, the truth is, these integers, which is all we're dealing from, we can see these go in and these go out. And I'm going to point out something more than this page. -3 isn't on either solution set, right? Because, well, -3 is neither greater than nor less than 5 when I plug it in, because it actually gives me the output of 5. And 5 isn't greater than or less than 5. So I anticipate that those questions are going to come up over here. It says, relate the solutions you found. All right, so one solution was, the first one was, let's see what it was. Looks like it was from -2 to 2. And I'll write it like this. The first one is, I realize x is greater than -2 and less than 2, right? And the second one, the second was, right, x is, well, this one's going to have to be written differently, right? That is less than -3, but greater than 3. So I am greater than 3, and x is less than -3. And since I can't be both, I'm going to write them separately. This says it is any real number, not just the integers. So what if I'm graphing any real number, right? Well, remember what the first one was. Here it is. The first one is actually everything a little bit less than 3, a bit bigger than -3, and less than 3, which is a weird thing, right? Because I can't use -3, and I can't use 3, but I can actually use all the fractions in between them like this, right? Same thing here. I can't use -3. I can't use 3, but I could have used the ones below it and used the ones above it, right, for this one. Go back and check your graphs and analyze this a little bit, and we're going to keep going. So, is it possible to describe the solution sets using inequalities that don't involve an absolute value? Yes, we just did it up here. It was these guys up here, and I'm just going to say it, right? It was -2 is less than x, which is less than 2. All right. Describe the solutions for this and this using inequalities that don't involve absolute value. Well, I did. We got negative 2 is less than x, which is less than 2. That's this one. And this guy right here was two separate ones. It was x being both greater than 3 and x being less than negative 3. All right. So we're going to start solving graphically when we get back. That is the first 2 pages, and we're going to continue with this guy right here when we get back. B on page 3.